Welcome to this explainer. Close your eyes for a second and just picture this. It's the year 2026. You're sitting in your doctor's office, right? You just wrapped up a pretty complex consultation, but instead of your doctor immediately turning their back on you to spend the next 20 minutes frantically clicking through drop-down menus and typing up notes, an AI system in the room automatically, instantly, and securely creates a fully structured clinical summary of the whole visit. Boom, it's done. The paperwork is completely handled. Sounds a bit like science fiction, doesn't it? Well, it's not. Generative AI is literally rewiring how medicine operates, all the way from the administrative back office down to drug discovery in the lab.
Okay, let's dive into this. Because honestly, whenever we talk about artificial intelligence in a super high-stakes field like medicine, this is exactly the first question on everyone's mind. Will AI replace your doctor? Let's just clear the air right out of the gate. The answer is absolutely no. This technology is being designed and deployed to support healthcare professionals, not to replace their clinical judgment. As we're going to see throughout this explainer, AI is stepping up as the ultimate assistant, not the ultimate decision maker. Here is our roadmap for today to unpack the hype from the reality. We're going to look at the 2026 healthcare reality, compare traditional and generative AI, look under the hood at how healthcare AI actually works, explore major healthcare applications, confront the real risks and challenges, and finally, look at the future of medicine. Let's get moving. Section 1. The 2026 Healthcare Reality. A day in the life of modern medicine. We really need to understand that AI has evolved way beyond those clunky customer service chatbots. We are talking about multimodal AI. By 2026, we're dealing with systems that don't just process text. They can simultaneously juggle text, images, and audio all at once. Picture an AI agent that doesn't just spit out an answer to a single typed question, but can actually listen to the spoken audio of your patient consultation, analyze your MRI scans, cross-reference your historical health records, and handle a whole bunch of steps to prep your file for the doctor. It is comprehensive, multi-sensory processing. Moving on to Section 2, Traditional versus Generative AI, the shift from predicting to creating. To really grasp the magnitude of what's happening here, we need a clear baseline. And this brilliantly illustrates the massive leap we've taken. On one side, we have traditional AI. This is the stuff we're used to. It's fantastic at predicting or classifying outcomes, but it relies on highly structured data. So it might scan an image and flag a potential risk factor. But generative AI, that is a whole different ballgame. It creates entirely new content. It doesn't just flag a risk, it can actively draft a clinical summary, write a detailed medical report, or even generate a custom explanation of a procedure tailored exactly to a patient's reading level. And crucially, it doesn't need perfectly neat data. It thrives on diverse, messy inputs like unstructured clinical notes, speech, and images. Section 3. How healthcare AI works. The mechanism behind the magic. Because it kind of feels like magic, right? But I promise you, it's not. It is a highly controlled, systematic process. And to really understand this, we need to look under the hood at these 4 specific stages. Step 1 is data input, where the AI takes in the raw info, patient history, lab results, maybe a spoken conversation. Step 2 is context retrieval, which we'll dig into in just a second. Step 3 is generation, where the AI actually builds the output, like drafting that report. But please look at step 4. I want to highlight this big time. Human review. A real, trained doctor or professional checks the AI's work before it is ever used. This step is absolutely non-negotiable. Before patient care is impacted in any way, human expertise has to validate the machine's work. Now, let's zoom in on that second step, context retrieval. This operates using something called RAG, or Retrieval Augmented Generation. Look, in a hospital setting, you definitely don't want an AI just guessing or pulling random facts from the internet. A RAG system forces the AI to securely retrieve relevant, highly verified medical guidelines and specific patient records before it even thinks about generating an answer. Basically, it grounds the AI in absolute medical fact. It ties the AI's response directly to verified reality, so it isn't just making things up. Let's jump to Section 4, Major Healthcare Applications, from administration to the clinic. We've talked about the theory, so let's look at the actual real-world impact. We're already seeing real-time AI clinical scribes securely listening in on consultations and instantly writing up the notes. Telehealth platforms are using AI to summarize your symptoms before the virtual doctor even joins the call. We've got AI taking all that messy data from your smartwatch and turning it into a clean, easy-to-read health summary. And think about the absolute administrative nightmare of healthcare. Well, AI is automating insurance claims, drafting discharge instructions, and running smart chatbots that handle routine FAQs and appointment reminders. All of these administrative tools are massively reducing the paperwork burden, improving cost efficiency, and saving incredible amounts of time. But again, any complex or urgent issues, those are always escalated straight to human staff. This tech is also bleeding into an entirely different realm of medicine, drug discovery. And this is genuinely mind-blowing. Traditionally, developing a new drug takes years and years of expensive trial and error just to find the right compounds. Generative AI is stepping in as a super-powered research assistant. It can actually propose entirely new molecular structures and predict exactly how those compounds might behave in the human body. It helps researchers zero in on which molecules are actually worth testing in a lab, which could literally shave years off the discovery process. Now, laboratory testing and human clinical trials are obviously still 100% required, but the AI is giving science a massive, massive head start. And here's a totally brilliant clinical application you might not have thought of: synthetic medical data. To train better AI and do deep medical research, you need massive amounts of data. But obviously, medical data is incredibly sensitive and private. Well, generative AI can actually create synthetic datasets. Basically, it generates fake data that mathematically mirrors real healthcare data, disease patterns, and demographics, without exposing a single actual patient's identity. It's a game changer because it allows for safe, rigorous medical research and AI training without ever risking human privacy. Section 5. Real risks and challenges. The high stakes of healthcare. Now, whenever you introduce cutting-edge technology into a literal life-or-death field, there is some very serious tension, which brings us to a completely valid natural skepticism. What happens when the AI is just wrong? Because as powerful as these AI models are, they have critical flaws. They are not perfect by any stretch. Let's break down these major risk factors, because these are the exact hurdles the industry is wrestling with right now. First up, AI hallucinations. This is when an AI generates information that sounds incredibly confident, but is completely factually incorrect. In healthcare, a confident lie is incredibly dangerous for patient diagnoses. Second, outdated information. If the data used to train the AI has strict cutoff dates and doesn't get real-time clinical updates, the AI might rely on older data, which can lead to obsolete or flawed care recommendations. And third, data privacy. Hooking AI tools up to electronic health records is technically complex, and exposing sensitive medical info would breach some of the strictest security regulations on the planet. This is exactly why this tech requires rigorous validation, nonstop testing, and ironclad operational safeguards. So the crucial takeaway here, and I really want this to sink in, is that AI-generated information related to patient care should always be reviewed by qualified professionals. We just keep coming back to our anchor theme. AI is a powerful collaborator, but human oversight is absolutely essential. The AI cannot and should not independently make final medical diagnoses. Which brings us to our final section, Section 6, the future of medicine, collaboration, not replacement. So, how do humans and machines actually integrate going forward? Well, the healthcare professional of tomorrow is going to need a whole new toolkit. To thrive in this space, workers and developers need specific new skills. A basic understanding of AI and machine learning is becoming fundamental. They're going to need a deep grasp of healthcare data standards and regulations. Doctors and nurses are going to learn prompt engineering, which is basically knowing exactly how to talk to the AI to get the best, most accurate outputs. They'll need to understand those RAG systems we talked about earlier. And most importantly, they will rely heavily on their own critical thinking to verify the AI's accuracy and hatch any of those dangerous hallucinations. For the tech folks building this stuff, Python and AI development frameworks are basically the new stethoscope. And this really brings us to the core thesis of this whole explainer. The overall direction of medicine is not about replacing healthcare professionals. AI is moving toward becoming an incredibly powerful collaborator that handles the grueling, repetitive, time-consuming tasks. The goal of bringing AI into the clinic isn't to remove the human element, it's to protect it. It's about allowing healthcare teams to finally step away from their keyboards and spend more time on what actually matters: direct, human-to-human patient care. So I'll leave you with this final thought to chew on. If generative AI steps in and carries the massive burden of paperwork, clinical notes, and data sorting, are you ready for a future healthcare experience where your doctor finally has the time and the freedom to just focus on you? Thank you so much for joining me for this explainer. I really hope this helped you structure your understanding of the incredible shifts happening in medicine today. Stay curious and keep learning.